Find the equation of the intersection of the cylinder, x minus 1 squared plus y squared equals 1, and the sphere, x squared plus y squared plus z squared equals 4. Hint, find x and y in terms of z. So the first thing I'm going to do here is I'm going to just take this equation here and I'm going to solve it for either x squared or y squared. So I'll solve it for y squared first. So I would end up with y squared equals 1 minus x minus 1 squared. Okay, now what I'm going to do with this is I'm going to sub it into the other equation for a y squared. And this will give me x squared plus 1 minus x squared minus, x minus 1 squared plus z squared equals 4. So I just took this and put it in place of y squared. Now I'm going to just simplify this. So that means I'm going to get x squared plus 1 minus, and I'm going to use a bracket here to separate the inside of this. This is going to be x squared minus 2x plus 1 plus z squared equals 4. So I'm going to get x squared plus 1 minus x squared plus 2x minus 1 plus z squared equals 4. Okay, now from here I'm just going to simplify, put together what I can. So those go away. My 1's go away. And then I'm left with 2x plus, oops, I forgot my squared on my z, plus z squared equals 4. So now from here, I'm just going to move my z squared over and divide by 2. Because remember, the hint said find x and y in terms of z. All right, so I'm just solving for x here. So my x then is going to equal, 2 minus z squared over 2. Now we're going to solve for, we're going to take this equation here and we're going to solve for x squared. Or x, excuse me. So the first step I'm going to do is just move that y squared over to the other side. So I'm going to get x minus 1 squared equals 1 minus y squared. And then I'm going to square root both sides. So I'm going to get x minus 1. And remember, when I square root, I get a plus or minus there as well. So it's going to be plus or minus square root of 1 minus y squared. And then I'm going to move the 1 over. So my x is going to equal 1 plus or minus the square root 1 minus y squared. Then I'm going to take this and plug it in the other equation. Because remember, I'm trying to find out where these two intersect. So I can use substitution in order to accomplish it. And that's really my whole reason for this all. I'm always taking one equation, solving it for a variable, and then plugging it in the other equation. That's how I actually find the intersections. It's not setting them equal to each other. In essence, what that is, that's just a substitution problem as well, but they call it setting them equal to each other, just so you know. It's really a substitution. Okay, so anyways, so we're going to substitute here now. So that's going to give me 1 plus or minus the square root of 1 plus, is it minus? Yep. Y squared plus y squared plus z squared equals 4. All right, now we're just going to expand this piece here by squaring it. But we don't need to worry about the plus minus here. sufficient to say, hey, let's just take the plus. It'd be a good exercise for you to see why it's not necessary to do the plus and the minus there. But anyways, let's get back to this. So now, when I multiply that out, that's times itself. So I'm going to end up with a 1 plus 2 square root of 1 minus y squared plus, and then now this squared is going to give me 1 minus y squared. And then I have this, the rest of this to write down now. Plus y squared plus z squared. Oops, I should move it over a little. Equals 4. All right, just enough room. So now I'm going to clean it up some. So this is going to be 1 plus 2 square root of 1 minus y squared plus 1 minus y squared plus y squared plus z squared equals 4. So those give me 0. I can put my 1's together. So I end up with 2 square root of 1 minus y squared plus 2 plus z squared equals 4. Now I'm just going to move these two pieces over to the other side because I'm trying to isolate the radical here. So that's going to give me 2 square root of 1 minus y squared equals 2 minus z squared. And then I divide by 2 here. So when I divide by 2 here, I'm going to get 1 minus y squared equals 2 minus z squared over 2. And then now I have to square both sides. That's why I actually take the square root. That's why I have the square root by itself, I mean. So now that's going to give me 1 minus y squared equals, and up top I'm going to get 4 minus 4z squared plus z to the 4th, all over 4. And then I'm going to subtract 1 from both sides. So minus 1 minus 1. And that's going to result in negative y squared, which equals, and when I move that 1 over, I'm just going to say minus 4 over 4. So I'm just going to tie it all in. And then this here is a plus 4. So I'm going to say plus 4 minus 4z squared plus z to the 4th, all over 4. So this is, when I subtract that 1 over, that's where this 4 over 4 comes in there. And the 4 stays on the bottom. But when I add, I just add the numerators over the same denominator. And then those cancel out. So then I have negative y squared equals negative 4z squared plus z to the 4th over 4. So then that's going to give me, when I put the negative over, y squared equals, let's see here, 4z squared minus z to the 4th over 4. And then the last step then is square rooting both sides. But I can pull a z squared out there, and I will, because that'll make that a little easier to deal with. And I don't have such a big square root that I'm dealing with here, over 4. And the final step gives me my equation. So that's going to end up being, for y is going to equal plus or minus z over 2 times the square root of 4 minus z squared. So this means I need one more thing, a parameter on my z. So my z is actually going to run from negative 2 to 2. So I can say z is an element of negative 2 to 2. And there is my equation. Now, some of you might think that I would have to plug this into any one of those two equations if I can. Now, the crazy thing is if I tried to do that, let's say I took those two equations, that x and that y, and I plugged it in here, what would happen is I would end up with 4 equals 4. So this is the best I'm going to get with this intersection. So that's our answer for that one.